Welcome everyone to this video. In this video, we are going to discuss about low test on DC series motor and experimental setup. Here, we are going to discuss the objective of conducting this experiment and then how to conduct this experiment. Let's go to the discussion. So, here, this is the circuit diagram for a series motor. Normally, in previous video, I explained how the DC motors are classified. According to the connections of the field winding, the DC motors are classified into shunt motor, series motor and common motor. In series motor, the field winding will be connected in series with the, so like this. So, this is what the series field winding. This series field winding has been connected to the corresponding motor. Okay. So, that is why it is called a series motor. So, here the number of turns in the series winding will be less. Number of turns in the series winding will be less, but the thickness of the winding will be high. Okay, the thickness of the winding will be high. Since it is directly connected to the armature, normally the current flowing through the armature will be high. Okay, compared to the field, the current flowing through the armature will be high. So, it will be approximately equal to the rated value. It will reach, when the load is high, it will reach rated current value. So, the maximum current will be, for example, if we are using a 5 HP machine, means the corresponding rated current will be around 20 amps. According to the design, it will be 20 amps. So, on that condition, normally for a DC motor, the field winding will have very thin wire, because the field current flowing through the field winding will be around 1 to 5% of the rated current. So, it will be around 1 to 2 amps for a 5 HP machine. So, in that case, if we connect the series field winding in series with the armature, the field wind, if the load increases, the current will increases. As IA increases, the current flowing through the field winding will also increases. During that time, what will happen? Due to the high current flowing through the field winding, the winding may get damaged. It may burst. So, in order to avoid that, the thickness of the winding will be increased, but at the same time, we should avoid the resistance drop. So, the number of turns will be reduced. Okay, so in order to reduce the drop in the field winding, the number of turns will be reduced. In order to avoid the damage during the rated current value, the thickness of the winding will be higher compared to the shunt field winding. So, this is what the DC series motor. Here, the current giving into the supply current will be same as well the field winding current, same as well as the armature current. So, we can write it as IA is equal to IF is equal to IL. IA is equal to IF is equal to IL. So, IL is nothing but the corresponding line current or load current we can represent. Okay, VL is nothing but the line voltage. Okay, IA is nothing but the armature current. This is IA, and IF is nothing but the current flowing through the field winding. So, in series motor, the current will be same. Okay, so the voltage equation will be V is equal to E minus V is equal to E plus IA RA plus IA RSC. So, we can write it as E plus IA into RA plus RSC. So, the corresponding armature resistance drop will increases compared to the shunt motor in series motor. Okay, in series motor, the armature resistance drop will be more. So, the line voltage, when you take the line voltage characteristics, so there will be more drop compared to the shunt motor. Okay. So, these are the different characteristics of DC series motor. So, as we discussed in the earlier video, so here also we are going to discuss 3 characteristics, electrical and mechanical characteristics. So, in which these torque versus armature current and speed versus armature current will come under the electrical characteristics, where the speed versus torque will come under mechanical characteristics. Okay. So, this is the torque versus armature current characteristics. Here in series motor, the corresponding fluxes field current will be equal to the armature current. As we discussed, field current will be equal to the armature current. So the torque equation, this is the fundamental torque equation. TA is directly proportional to phi Ia. So phi is directly proportional to If, which can be represented as Ia. So what happened? The corresponding torque equation will become Ia square. This will be the square of torque will be square of the armature current up to the saturation condition. Up to the saturation condition, the corresponding torque will be directly proportional to Ia square. A small amount of current increases in the armature itself gives high torque. That is the representation of that equation. So after saturation, what will happen? After saturation, the flux will not be increases. Saturation, above the saturation level, the flux will not increases. So the flux will become constant. So the varying component will be alone Ia only. So after the magnetic saturation level, okay, the torque will becomes directly proportional to Ia. So up to Ia saturation level, it will increases exponentially, okay, Ia square, okay, square times it will increases. After that, it will come to a normal increment, okay. So that's why that's what the torque versus armature current characteristics, okay. So this up to this condition, we will have saturation. After this point, okay, saturation has been occurred, so flux will become constant. So this is what torque versus armature current characteristics. In speed versus armature current characteristics, earlier we see same equation, N directly proportional to Eb by phi. So here the current increases, the speed will decrease, okay. So it will seems to be a parabolic one, okay. So that this motor should not be started without load, okay. So current if the current is high, Ia is nothing but the armature current. Armature current will increases when load increases. Armature current will increases when load increases. So when load increases only, then only the armature current will keep on increasing. So when load is 0, the armature current will be 0. As armature current is 0, 1 by 0 will be infinity. So high speed. So N directly proportional to 1 by 0. So N is directly proportional to 1 by 0. So infinity. That's a higher value. So what will happen? The machine will run at a very high speed. So in order to avoid this concept, the motor should not be started without any load. So as we connect the load, there will be a small amount of current. So due to that small amount of current, the motor will run at a certain speed. So as well as we increase the load itself, the speed will reduces, okay. So load increases means the speed will reduce. So this will happen for all kind of DC motors, okay. So as the speed increases, the torque will decreases. As the speed decreases, the torque will increases. That is the concept. So that is why the DC series motor should not be started without a load. So before starting the DC series motor, we have to apply some load. Then only we could able to start the motor. Otherwise, the speed will be predominantly high. So it will damage the shaft of the machine. So sometimes it can break down or it can damage the load side. Okay, anything can be happen. So this kind of series motor normally used in lift process. They are using series motor. Nowadays also they are using series motor in the lift. Elevators also they are using series motor. This is the speed torque characteristics as we know earlier. Okay, speed and torque will be inversely proportional. So that's the same equation. This speed torque characteristics will be a replica of speed versus current characteristics. Okay, because torque is directly proportional to Ia square, square root times reducing. That's all. So the characteristics will be similar to the speed versus current characteristics. Okay. This is the performance characteristics of the DC series motor. So this curve represents the efficiency versus output power. This curve represents the speed versus output power. This curve represents the torque versus output power. This line represents the load current versus output power. So this is our objective. This we are going to draw this graph alone. Okay, we are going to measure the line current, we are going to measure the speed, we are going to calculate the torque and the efficiency, and we are going to calculate the output power also. So another mechanical characteristics, this is a similar one, okay, what we discussed earlier. So what are the precautions we have to make for a load series motor, load resistance series motor? So before starting the motor, we have to ensure that the load has been given, okay, load has been given to the motor. So that we already discussed, the DC series motor should not be started without loading condition. We have to start the motor with the load only. Okay, the fuse has to be selected. It should be 125% of the rated current. So from the nameplate detail, we have to note down the rated current of the machine, and 125% of the rated current has to be calculated, and the corresponding fuse rating has to be fixed. Okay, so the switches whatever we are using should be in the open condition. Okay, and we have to verify the measuring device like voltmeter and ammeter or MC meter, that is nothing but the moving coil meter. These moving coil meters are used for DC measurement. We have to verify whether it's a MC or MI. Okay, MI meters are used for AC meters, AC measurement. And then we also verify the null point of each measuring device, whether the indicator shows 0 or it shows some other value. We have to verify it, and we have to calibrate the meters also. So this is the circuit diagram. Okay, so from the left side, okay, this is the positive of the positive side of positive as well as the negative of the supply. Okay, so we are giving 220 volt DC supply to the machine. So this is what the DPSC switch. Okay, and fuse, this fuse will be 125% of the rated current. So this is the ammeter. Ammeter will be connected in series with the line. Voltmeter connected in series parallel with the source. So when you close the switch, you can able to measure how much voltage will be coming to the input side. Okay, here we are using 2-point starter. Since the field winding is connected in series with the motor, we are using only 2-point starter. In 2-point starter, we will have L plus and L minus terminals, input and output terminal. Okay, and the corresponding this point will be the input of the field winding F, and this will be the output of the field winding FF, and it will be given back to the armature of the motor. So this represents the mechanical coupling. This symbol, hash symbol, represents the mechanical coupling. Coupling device will be there which couple the motor with the brake drum. This is the load brake drum roll, and this is the weighing machine to measure the weight of the load. Okay, so this is what the circuit diagram. It's a simple circuit diagram. We could easily connect the components. So procedure. So we have to start the motor first. Okay, first check the connection and then start the motor using the 2-point starter. Note down the reading when there is some load, and then what we have to do, we have to apply the load further. Okay, up to the rated current value. So we have to calculate the corresponding voltage, VL value, current IL current value, speed value, the corresponding weight of the S1 and S2 for each measurement. So we have to note down the values up to the 120% of the rated. So from that readings, we can calculate the performance characteristics and the mechanical characteristics of the machine, and we have to tabulate it, and we have to draw the graph. This is the tabulation. So as I told you, we will measure the corresponding line voltage, line current. Okay, the line voltage will be considered VL, the line current will be considered IL, and the corresponding S1, S2 will be there. The difference of the S1, S2, it's polarity independent. Okay, difference of the S1, S2 will be considered, and speed you will measure. The torque, output power, input power, and the efficiency will be calculated according to the formula. The circumference of the brake drum will be measured.
Now we are going to perform some experimental setup in our lab. It will shows how to give connection for the given circuit diagram and how to measure the reading and tabulate the same for this experiment. Let's go to the demo video.